All right, so welcome to the Descriptive Data Analysis lab. The goal in this lab is to get a deep dive into the data that we're going to work with. We're going to work with the Gapminder dataset, so you probably need to install the Gapminder dataset. So you can just type install .packages and then pass it Gapminder. This is a data set that's actually super interesting. It has like population data and life expectancy, GDP, all kinds of different metrics for countries across the world since 1957, I believe. We're going to work with this quite a bit, even though this data set is well documented. The point of this is to do a deep data exploration. So we want to look at it from a whole bunch of different ways. We want to look at it qualitatively, understanding the variables that we have, and we want to look at it quantitatively, understanding, how those variables are distributed. All right, so without further ado, let's go ahead and load in our libraries. So we're going to need the tidyverse as usual. And we'll pass the tidyverse. If you haven't installed any of these, go ahead and do that now. We want the Dipler library, the DPLYR, and we want the Gapminder library. And this is how we're actually going to bring in the Gapminder dataset, because even though it comes it's an R package. So this data set doesn't come pre-installed with R, so it's not one of those toy data sets that's in R already. Rather, it's a data set that functions like a package. There's quite a few of these, Jane Austen's novels, the OkCupid data set. There's so many of these kind of packages. You just need to go and look around. We will go ahead and highlight all of these and hit Command Enter, and it will run these packages. You might get an error message asking if you want to restart R. Go ahead and select yes. And I cannot open the package because I am not connected to the internet. So that you are connected to the internet. If you're not, you may have to get an internet connection in order to install the package before you're going to be able to work with the Gapminder dataset. All right, so we have never worked with Gapminder dataset before, so we want to find out about it. The way that we do that is we type 2 question marks and then pass it Gapminder. And what that's going to do is tell us a little bit about the Gapminder dataset over here. So if this help screen wasn't up already, it is now. You can go ahead and click on this Gapminder : Gapminder. That's the one that we're using. The unfiltered is a much larger data set, which is fine. We're just using the filtered one because all we want to do is illustrate how to do this work. All right, so we see here that, it's giving us a description, an excerpt of the Gapminder data on life expectancy, GDP, population. It tells us the format, how many rows, and how many variables. We have 6 variables: country, which is a factor, continent, which is a factor. So those are qualitative variables. They are not quantitative. We have year, which doesn't tell us what type it is, but we will find that out in a minute. Life expectancy, population, and GDP per capita. And then it gives you a little bit more information. You can go out to gapminder.org/data. You should include some of the information about how your data was collected for your exploratory data analysis lab, or assignment rather. So for this, you don't need to include a write-up of how the data was collected, but when you turn in your first project, you will need to explain, it was collected from these countries, it was imputed from those countries, or whatever is relevant for your data. So we're going to go ahead now and use a couple of different summary types. The first that we're going to use is summary. And summary tells us the distribution of each of our variables. So type summary Gapminder, hit Control Enter, and then we have here each of our variables. So here's our 6 variables. For the quantitative variables, we have the minimum. So the first year was 1952, not 1957. The last year was 2007. The minimum life expectancy is 23.6. The maximum is 82. And then the populations and the GDP per cap. All right. You'll notice over here that country and continent don't have this distribution laid out, and that's because they're qualitative variables, obviously. What this is telling us is that Afghanistan appears in the data set 12 times, and then it's telling us there are 1,632 other entries that are not listed here. It's also telling us that how many times each continent appears in the data set. So Africa as a continent appears 624 times. That means that there are 624 entries for countries in Africa for different years. And that's typically how qualitative variables get described in summary. Now, if you want to understand how many observations there are, the type of data each observation is, then you'd use glimpse. So I often use both of them just because they give me different information. So if you glimpse the Gapminder dataset, you get these 6 variables again. It tells us the first 2 are factors. We were expecting that. Year is an integer. Life expectancy is a decimal number. Population is an integer. And GDP per cap is a decimal number, exactly as we would have expected. It also gives you a preview of the first few entries in whatever order the data set was read in. The last thing that you do, just to kind of like orient yourself around your data, is call head and tail. And this I do just to like understand how my data is structured. I often find this to be really helpful to make sure that whatever I got was what I was expecting, that my data just looks right. We've talked about this in class, but the strength of cleaning and manipulating and understanding your data in a program like R versus something like Excel is that in R it's reproducible. You can take different data sets and do the same steps, and you can trace your steps back and see what happened. The drawback is that you don't get that really helpful like view into your data that you get when you're using something like Excel. So head and tail give you that. So we'll go ahead and run that. And what we get back is the head gives us the first 6 entries. So we have the country, continent, year, life expectancy, all of this. And the tail, it looks the same. So this is great news. We already knew this because this was a data package, but sometimes you'll get a data set and it'll look fine at the top and you'll be like, yeah, that's exactly what I was expecting. And then you'll look at the tail and you'll be like, there's no data here. Or, all the missing data points will be at the end. And then you know that you're going to have to go in and do a little bit more cleaning. So it's always good just to look at both the head and the tail. Now we're going to do one more kind of cursory view into the data from a very distant. We want to know how many null items are in here. How much missing data is there? A really easy way to do this is you go sum, and then you just sum up all those that are NA. So sum is NA, and then everything in the Gapminder. And then this will tell us there is no missing data. That's not surprising. This is a really great data set, but it's good to know. So, all right, we are now going to do different things and look at different things in our data set. So there's really, in Dipler, which is the package that we're going to be using, there's 5 functions that operate on 3 different categories. So we have our variables, which are columns. We have select, which picks certain columns. Filter, which picks only the rows that meet the criteria of a certain column. For our rows, we have arrange, which sorts a table. And we have mutate, which you can like change things. You can change a column. You can change all the rows in a column with mutate. The last one is we have for groups, we have summarize. All right, so let's go ahead and try those out. So we're going to make some new variables. Our first we're going to call GPCNT life. And what we're going to do is we're going to select only the country and the life expectancy columns from the Gapminder dataset. So it's a GP for Gapminder, CNT for country, and life for life expectancy. We'll assign that to a new variable, and we will select from Gapminder, comma, country, and life expectancy. That's not what I want. Life EXP. Go ahead and run that. And I have a typo. It is a small l, not a big L. There we go. And we want to make sure that it works, so we will call the head on GPCNT life expectancy. We'll run that, and that looks exactly like what we were expecting. We were expecting a table that had only country and only life expectancy. You can do this same thing with absence. So rather than selecting the country and life expectancy, let's select everything except the population. So I'm going to call this GP no pop, and I will assign it to select from the Gapminder dataset everything that isn't, so negative POP. And go ahead and run that, and it is actually pop, not population. And then we'll look at the head of that, GP no pop, and run that. And that looks exactly like what we were expecting as well. We have the full data set with everything except the population. Both of these are just helpful when you want to create new data sets, but you don't want a bunch of extraneous columns that you're not going to use. All right, so the next one is we're going to filter for a specific country or specific year. We're going to start with the year, and we're going to filter for only things in 1957. And we'll assign this to a new variable. So we'll call it GP 1957, and we will assign it to, we're going to take the Gapminder, and then we are going to pipe it over to filter by only the year where it's equal to 1957. All right, and then we'll go ahead and run that. And if we look at the head of that, we have only 1957. You see up here we had 52, 57, 62, 67. Here we only have every country in 1957. It might be, a little bit more interesting to glimpse this at this point. I'm just going to put this in here so that you see that there's so many other ways to look at your data. So if we were to glimpse this, we'd look here at year, and all of them are 1957. Again, this is exactly what we were expecting. All right, we're going to keep moving on and filter by a country. We're going to look for the United States. So I'm going to call it GP US, and we're going to assign that. And we're going to filter the Gapminder dataset, and we'll pipe it over, filter where country is equal to United States. Now, if we had written this in all lowercase, or if we had written it in all uppercase, Gapminder would, or R would not be able to find it. Let's go ahead and check to make sure that worked. We'll go ahead, GP US, and then we'll look for the first 7 rather than 6 entries, just to illustrate that we can look for different numbers of entries. So this gives us the first 7 entries for just the United States. We see that they're at all of these different years, 5 years apart. Awesome. So that's great, but sometimes you want to filter for 2 variables. So we are going to filter for just Asia in 1957. Okay, so we're going to filter for 2 variables. We'll call this GP 1957 Asia. We will assign it to this, and we'll do Gapminder that has been piped over to filter. where year is equal to 1957 and continent is equal to Asia. All right, I'll run that. Check out the head, GP 1957 Asia. That looks good. That looks like only Asian countries, only Asian continent. If you wanted to look at, say, 15 entries, you could do comma 15 here. Again, those are all in Asia. Great. We have gotten pretty far. Sometimes, though, you're going to want to output this into another format, like you want to download it as a CSV file. So we're going to write our data set. So we're going to go write.csv. We're going to pass it this data set that we just created, the 1957 Asia. We're going to call it Gapminder 1957 Asia.csv. Close quotes, close parentheses. We'll run that. All right, so you notice here that I didn't put any folder directory or anything like this. What that means is that this is going to save this file wherever your R images are saved. So, are running where my root directory is. That's just where I installed it. So that's where I will be able to find this file. Here that I have R installed like all the way up in my root directory. I have users MAM for my name. And here is where this file is. You may want to save it somewhere else. If you do, you can put in like desktop / and that'll save it on the desktop. If your desktop can be seen from wherever R is installed. This may take a little bit of trial and error. If you absolutely cannot find it, be sure to send me an email and we'll look at it before class the next time we meet. All right, so now we're going to get started with some operations on the rows. The first thing that we're going to do is to sort by population. We'd like to find like the top or the smallest populations, or maybe we'd like to find the largest populations. So we're going to call the Gapminder dataset. We're not going to assign it to a new variable because ultimately that's not really necessary for this purpose. But if we wanted to save it for later purposes in this format, we would definitely assign it to a new variable. All right, so we're going to call Gapminder. We're going to pipe it over to the arrange function, and we're going to arrange by population. And we do that, and we see the smallest populations are up at the top, like Sao Tome and Principe in 1952 and 57 had less than 1,000 people, very small. So let's say that we didn't want to find the smallest countries, but instead we wanted to find the largest countries. We'll do the same thing. We'll call the Gapminder dataset, pipe it over to the arrange function, but this time, instead of just calling arrange by population, we'll say arrange descending by population. Let's go ahead and run that. And now you see the largest countries, which not surprisingly is China in 2007 and 2002. And, you know, many, many more years. So that's great. But what if you wanted to both filter and arrange? So let's say you wanted to see in 1957 what were the largest populations, right? Because just descending it, you're always going to get the most recent years. That's just how population has worked. And so the only way to get at that information is to filter. So again, we're going to call Gapminder, and we're going to pipe it over to the filter function first. So first we want to filter on the year. We'll call 1957, and then we'll pipe that over to the arrange function, and we'll call it descending on population. Run that, and now we see in 1957 the largest countries were China, India, the US, Japan, and Indonesia. And you could do the same thing by filtering for 2007 and looking at the smallest countries or any combination thereof. All right, cool. So this is great, but this population, particularly for the larger countries, is kind of hard to understand in this raw number. It might be more beneficial to us if we saw it in millions. So let's make a new column, and we'll call it pop mill. So we will do the same thing. We'll call the Gapminder dataset, and then we'll pipe it over this time to the mutate function. And we'll call it our new column, pop mill, and this will be the population divided by 1 million. 1, 1, 2, 3, 1, 2, 3. All right, go ahead and run that. And you see that nothing changes, right? Oh, no. You see that we have our population in millions laid out here. But it's no longer filtered and is no longer arranged. And this is because we didn't save these filters and arranges to a new variable. So these are just temporarily stored in memory. So now if I call the Gapminder dataset, call the head of the Gapminder dataset, you see that this pop mill doesn't actually exist because it was only held temporarily in memory. It wasn't stored permanently. If I wanted to add a column to the Gapminder that was pop mill, I could say Gapminder, and then I could assign it to this phrase, this sentence up here. I can just copy this down and put that there. I don't actually want to do that, but I could if I wanted to. I don't like to do that because particularly for data sets you load from a package, or really even if you're loading your data set from a file, you don't want to manipulate the first thing that you called it, because you always want to be able to go back to the Gapminder unadulterated. This is if you make any mistakes or things like that. It's actually quite a pain to have to go all the way back and rerun all of your code. So if we did want to store this, we'd probably call it something like GP additional columns. You know, you would give it a different name just because you wouldn't want to overwrite the original Gapminder variable. All right, so that's great, but let's say that we wanted to know, we wanted to multiply two columns together. So you see here that in the Gapminder dataset we have population and GDP per capita. Wouldn't it be great if we had a measure of GDP, not just GDP per capita? Well, we can get that with the mutate function. So we'll call Gapminder again, and we will pipe it over to mutate, and then we'll have our just plain old GDP, and that will be population times the GDP per cap. Go ahead and run that, and I probably have a typo here. You may have seen that I have GPD, not GDP. All right, we'll go ahead and run that. And now we have the complete GDP for each country, and this is the population times the GDP per capita. All right, excellent. Now, let's find the top 5 highest GDP countries from 1957. So this will require us to use the mutate to get the GDP, so we'll use that first. Use filter to get only 1957, and then we'll arrange those values. So let's go ahead and build that up. So we'll start with the Gapminder. Start with the Gapminder dataset. We will pipe it over to, and I'm going to hit enter so I can keep it nice and organized. Pipe it over to mutate, and then we'll call our GDP equals our pop times our GDP per cap, right? And then we will pipe that over to filter because we only want where the year is 1957. And then we'll pipe that over to arrange. And we want to arrange descending by GDP, right? All right, so we'll go ahead and run that. And Gilter is not filter. Go ahead and run it now. Excellent. And then we have the top 10 actually highest GDP countries in 1957. What we have here is no surprise whatsoever. All right, so let's turn our attention to life expectancy now. And we're going to ask a more general question. We want to know, what is the mean life expectancy for the entire data set? This is actually not that illuminating when you're talking about a bunch of different countries and a bunch of different years, because the answer that we're going to get is basically going to be, what is the mean life expectancy for the whole world from 1952 to 2007? It would obviously be better to pick one year, but for the purposes of illustration, we're going to do this broad mean. All right, so we're going to take the Gapminder dataset. We're going to pipe it over to the summarize function. And we are going to summarize, we're going to call mean life exp. And then that is going to be the mean of the life expectancy column. So this is literally the mean of the entire column. And from 52 to 2007, the mean life expectancy globally has been 59.5. Like we said, it'd be way more interesting if we found it for just 1 year. So let's look at the life expectancy for 1957. So we'll take the Gapminder dataset, we'll pipe it over to filter first, and we'll filter on the year 1957. And then we will pipe that over to the summarize function, and we'll call the exact same thing, mean life exp, and it'll be the mean of life exp. All right, run that. And the mean life expectancy in 57 was 51.5. Let's just check it out. So just for the sake of interest, 50 years later, in 2007, it was 67. So globally, it increased by 15.5 years, which is pretty impressive. All right, so now let's find the global mean life expectancy for 1957 and the world population for 1957. So I'm actually going to copy this piece of code here. I'm going to paste it there. And after the mean life expectancy, I'm going to put a comma because I'm still summarizing. And I'm called total pop. And then I'm going to add the population. I need to specify that I want to add it as numeric. It is actually a numeric variable, but it is just good practice to summarize as numeric when you have multiple different variable types in your data set. It just leads to less problems down the road. All right, so we'll run that, and we find that the mean life expectancy is still 51.5, and the total population of the world in 1957 is something too large for me to figure out how to say on the fly. All right, so from here, we're going to add one more thing. We are going to also filter by, or we're going to group by the continent. So we're going to copy this piece of code again, because ultimately we're just going to edit it. And we want the life expectancy and total population of every continent in 1957. So here after mean, or here after filter, before summarize, we are going to call group by, and we are going to group by continent. And then we're going to pipe that grouped by expression over to the summarize. And here we get, for each continent, the mean life expectancy and the total population for 1957. And we see here that Oceania had the largest and Africa had the smallest. Excellent. All right, now I'd like you to take a few minutes and play around with this and try to find the mean life expectancy and the GDP of the United States or any other country in the year 2000. So you'll use the expressions that we've used thus far in order to figure that out. All right, take a few minutes to work that out now. The instructions are also in the notes, and I'll meet you back here when you're done. All right, so I hope that that was fun. We are going to do one more thing. We are going to group by not only the continent, but the continent and the year. So summaries aren't just limited to one variable. We're going to find the mean of life expectancy and the total population grouped by continent and year. So rather than having the filter here, we'll remove this. And we'll put here continent, comma, year. Go ahead and run that, and you see that we have here Africa 1952, 57, 62, and the variables that we were calculating. Excellent. So now you can go ahead and find the mean GDP for every country and every year. Go ahead and take a few minutes to work that out. Again, the instructions are in the notes for this lab. All right, I'll meet you back here when you're done. So now we're going to move on to doing a few visualizations. The first thing that we'd like to visualize is life expectancy by year. We need to do some transformations on our data set and save it to a new data set. And we're also going to use the Ggplot library to visualize our results. Ggplot comes with the tidyverse, so when you loaded the library tidyverse, you also loaded Ggplot. Right, so the first thing that we want to do is make a scatterplot. And we are going to take our Gapminder dataset and we're going to group it by year because we would like our x-axis of our scatterplot to be the year. Maybe we'd like to see population and mean life expectancy over time as it changes. All right, so I'm going to make a new data set and I'm going to call it by year. And I'm going to assign it to my filtered view of the Gapminder data set. So I'll take Gapminder and I will pipe it over to group by, and I'm going to group by year. And I will pipe that over to summarize, and then we'll have total pop equals sum as numeric of the population, parentheses, comma, and then mean life expectancy will be the mean of life expectancy. All right, so we'll run that, and unlike previously, we have saved this to a new variable. So we can call the head on the by year data frame, and we see that our two columns that we calculated are actually saved here in our by year data frame. All right, so now we're going to use Ggplot. So we're going to call Ggplot, and we'll call the by year as our data frame. Our aesthetic will be that x is the year, because we want the x, we want year along the x-axis, and along the y-axis we want the total population of the world. So we are going to make a we're going to make a scatter plot of the total population by year. So we have our base call, and now we need to tell it what geometry we want, and we want a point. So I'll have our geom point. Okay, go ahead and run that, and total pop. Total pop doesn't exist, but total pop should. No, that's because I have a typo up here, so we'll run this whole bit of code again. All right, and we see the total population of the world increasing quite steadily from 1952 to 2007. This is exactly what we would expect. Unfortunately, it's actually not that interesting. So, a couple of things to note about this. Before we make our plot more interesting, let's notice here that our plot started at the lowest value of the x-axis. Now, sometimes that is definitely the best thing to do. It's probably the best thing to do here. However, if you need your visualization to start at 0, like let's say you're looking at multiple scatter plots next to each other or multiple line plots next to each other, and they have different minimum values on the y-axis, then you definitely want to have your y-axis start at 0. It's not actually visually possible to compare them otherwise. So let's expand our limits. We're going to take this exact same piece of code, we're going to copy it down here, and we're going to add another line to it, which is just expand limits, which is right here. And then our y-axis is what we want to expand, and we want to have it go down to 0. All right? And you see here the population starting at 0. And if you wanted to make multiple visualizations, this is just good practice here. All right, so now it would be way more interesting if we could break this down by continent. Unfortunately, the way that we grouped our Gapminder dataset, we didn't include a grouping by continent. So let's make a new data frame, and we'll call it by year continent. And we will group by both of them, continent. All right, and we are going to assign it to Gapminder, which will be piped over to the group by function. And we are going to group by both year and continent. And then we can pipe this over to summarize. And we will summarize. I'm actually just going to steal this piece of code right here because I don't want to type it anymore. We're going to summarize by the total population and the mean life expectancy. So we will go ahead and run that. Group by has an underscore and no error message, so we can assume that it worked, but it's better to check it. And if we check it there, we get our year and our continent and our total population and our mean life expectancy. All right, what this allows us to do is then use continent for the color. So we'll call Ggplot again, and we'll pass the by year continent data frame. Our aesthetic, again, will have the y-axis equal to year, and the x-axis equal to year, and the y-axis equal to total population. And then our color is going to be equal to the continent, now that we have the continent variable to work with. Again, we will make this a point. You are welcome to make it a line as well if you would prefer. And we will expand our limits so that the y-axis goes down to 0. All right. And now we have a potentially more interesting visualization here, looking at population broken down by continent over this time frame. All right. So I'm going to have you go ahead and take a couple of minutes now to visualize the mean GDP per cap of each continent as a function of time. So you're going to do the exact same thing that we just did, except that rather than using the total population, you will find the GDP per capita as it changes over time. All right, so go ahead and take a couple of minutes to do that, and I'll meet you back here for this last part of the tutorial. Welcome back. Hopefully you were able to do that with no problem. The last part that we're going to do now is to kind of go over what a descriptive data analysis looks like and what I expect you to be turning in for your first project. So this is going to be specific to the Gapminder dataset. Obviously, how you describe your dataset is going to be unique to whatever dataset you're working with. So we have this information about population at the continent level, at the country level, at the global level. For reporting the general statistics, you know, here it'll be interesting to pull out a couple of like unique countries that are the most like China, or countries that have the smallest population, like Sao Tome and Principe. Maybe a country with the largest GDP in 1957 or 52 and 2007. So that's how you'd use country information here. You report a lot of the general trends at the continent level. Even though that abstracts the data quite a bit, in a descriptive analysis, you'd probably want to keep it around that level, giving the broad context and giving a few narrow points, but keeping it around the continent level because there's essentially 5 populated continents. And that's way easier to talk about and way easier to manage than like however many hundreds of countries are listed within this data set. All right. So the first thing that you would do is just give kind of an overview, which would be the summary, which we already talked about here. Another thing that you might want to do is talk about the minimum and maximum country for each one of those metrics. In this particular data set, we can leverage that by just filtering for the year 2007. And this code here, so I've made a new data frame, and I'm going to call for a row that has the minimum of life expectancy, the minimum of population. And I use these hard braces to call just that row, to say which one is the minimum. And it'll return you the whole row. It does that because we have this, we've specified it here with a comma. If you specified something after the comma and before the comma was empty, then you'd return the entire column. That's a little bit more advanced, not something you really need to know. Just need to know that this is how you'd find the minimum or the maximum for each country in the year 2007. So you might also want to understand how population has changed. What's the overall population growth rate over those 55 years? There are ways to do this that are a little bit more advanced and we'll talk about when we talk about correlation and regression. But I wanted to point out that you can always use R as a really advanced calculator. So you can make your population growth rate by subtracting the starting population from the ending population and the starting year from the ending year, and just divide the two, right? And that gives you your rate. How much has the population changed over this time? And you can find the minimum year by just calling min on the year column. And you can find the maximum year by calling the max on the year column. All right. I'm kind of breezing through this, but I do expect you to work through all of this code on your own. You'll also need to work through it for your first project. All right. Other things that you can do is create a visualization just like we did before, summarized by the continent and the year. Here we've grouped by continent and year, and we've included life expectancy, population, and GDP per capita. We can use that to make a visualization of all three, just like you did before in the visualization section. All right, the last thing that we're looking at here is like grouping by the continents and then summarizing by finding the maximum life expectancy and the minimum life expectancy. And you'd want to do this individually for each and every measure. This is one way to get at that information. It's one way to get at the range of continent populations, the range of GDP per capita, the range of life expectancies. This obviously requires a whole lot of manual labor. You'll repeat this a whole lot of times. There's another method to go about this that we're actually not going to fully introduce until we get into the text analysis lab. But just to kind of talk you through the logic, what we've done here is we've made a list of the continents, the 5 populated continents, and then we're going to use a function. So we're going to use the sapply, which means like applying a function. If you're familiar with other programming languages, this is lambda calculus. R just uses a different name for it. You're going to pass the My Continents data frame, and then you're going to define your function. And your function basically says for each continent, take the Gapminder dataset, filter the continent by continent, so give me each one individually, and then offer a summary. So do the summary like the original summary that we were using. And then that ends your function. And then you will have, it's not very pretty, it's not nicely formatted, but this will automatically, for each continent in your My Continents list, it'll filter the Gapminder dataset on this continent. All right, and that will give you the range of populations, the minimum and maximum population, all of the things that you got out of the summary, but broken down at the continent level, which is a little bit more manageable. All right, if you have any questions, if you come up with any problems, please let me know as soon as you can. I hope that you've enjoyed this tutorial, and I look forward to seeing your descriptive data analysis. Please download this R code and submit it via the LMS. Thank you so much, and I'll see you next lab. Bye-bye.